The greatest miscalculation humanity ever made regarding the avian world was dismissing the duck as a clumsy, comical fixture of backyard ponds and children's storybooks. We watch them waddle awkwardly across muddy banks, listen to their rhythmic, nasal quacks, and assume we are looking at a simple, harmless herbivore designed to float passively through life. But if you strip away the cartoonish veneer and look at the raw biological engineering of this creature, a terrifyingly sophisticated truth emerges. The duck is not a passive dweller of the water. It is a highly advanced, all-terrain biological machine engineered for total planetary survival. Long before humans designed amphibious military vehicles, submarines, or stealth aircraft, evolution had already combined all of these technologies into a single feathered chassis. With over 120 species spread across every single continent except the frozen interior of Antarctica, ducks have quietly established a global network that thrives in the face of environmental collapse. They are the ultimate masters of three distinct realms: land, air, and water, operating with a level of anatomical precision that makes human engineering look rudimentary. To understand the sheer perfection of this design, one must first look at the fluid dynamics of their feathers. A duck's plumage is not merely a coat for warmth. It is a highly pressurized, self-regulating structural shield. Ducks possess a specialized gland at the base of their tail known as a uripygial or preen gland. This gland secretes a complex, chemically dense oil that the duck meticulously spreads across its entire body using its bill in a continuous, ritualistic maintenance routine. When this oil bonds with the microscopic, interlocking barbules of their feathers, it creates a completely impenetrable, hyperhydrophobic barrier. Water does not simply slide off a duck's back. It is physically incapable of touching their skin. Even when diving dozens of meters beneath a freezing subarctic lake, the duck's core remains entirely dry and insulated. Beneath this waterproof outer armor lies a dense layer of trapped air pockets that serve a dual purpose. They provide an unbreakable thermal barrier against deadly temperatures and act as an internal, self-adjusting flotation vest that allows a bird to control its buoyancy with microscopic muscle twitches. But the true genius of their engineering lies beneath the surface, hidden in the freezing mud and ice where their feet operate. Humans walking barefoot on winter ice would succumb to frostbite and tissue death within minutes because our warm blood would rapidly lose its heat to the frozen ground, shocking our cardiovascular core. The duck solves this fatal thermodynamic flaw through an incredibly sophisticated vascular network called a rete mirabile, or countercurrent heat exchange system. The arteries carrying warm, oxygenated blood from the duck's heart down into the feet are tightly interwoven with the veins bringing freezing blood back up from the icy water. As the warm arterial blood flows downward, it automatically transfers its heat to the cold venous blood flowing upward. By the time the blood reaches a duck's webbed feet, it has already cooled down almost to the temperature of the ice, preventing any further heat loss to the environment. Meanwhile, the blood returning to the chest is safely warmed back up before it can shock the internal organs. This allows the duck to stand effortlessly on solid ice for days at a time, completely immune to the freezing elements that kill other species. This structural perfection extends directly to their propulsion systems. A duck's web foot is a masterpiece of kinetic engineering. When the foot pushes back through the water, the skin completely expands, creating a massive, flat surface area that generates maximum forward thrust. But when the duck pulls its leg forward for the next stroke, the foot doesn't drag against the water. Instead, the joints flex, the webbing automatically collapses inward, and the toes fold close, reducing drag to practically zero. This mechanical efficiency allows them to navigate raging river currents, coastal tides, and dense aquatic vegetation with minimal metabolic energy. They do not fight the physics of water. They flow through it, exploiting the fluid properties of their environment to maintain constant, effortless mobility. Yet, this mastery of the water is only one-third of their operational capability. The exact same bird that floats with absolute stillness on a misty lake can launch itself into the sky with explosive, vertical kinetic energy. Unlike heavy terrestrial birds that require long-running starts to achieve lift, many duck species, particularly dabbling ducks, can transition from a stationary floating position to full, high-speed flight in a single, violent stroke of their powerful pectoral muscles. Once in the air, their sleek, cigar-shaped bodies minimize wind resistance, turning them into high-speed biological projectiles. They can lock their wings into rigid, aerodynamic airfoils, slicing through turbulent weather systems at speeds exceeding 80 miles per hour. They are built to move, built to survive, and built to colonize. But as these avian machines conquer the open skies, they unlock a secondary, even more terrifying capability, a global positioning matrix that allows them to navigate across continents without a single human instrument. Every autumn, a silent, invisible shift ripples across the hemisphere. As the sun dips low on the horizon and the first winter frosts begin to lock down northern lakes, millions of ducks across the globe simultaneously look to the sky. They do not hesitate, and they do not get lost. They launch into the upper atmosphere, forming massive, aerodynamically perfect V formations that stretch across horizons. This is the start of the Great Seasonal Migration, a massive, synchronized movement of biomass that requires a navigation system so advanced it makes human GPS networks look archaic. A migrating duck can fly continuously for thousands of miles, crossing featureless oceans, tracking through blinding storms, and navigating dark, starless nights to arrive at the exact same square meter of wetland they occupied the previous year. They do not navigate by memory alone. They are plugged directly into the quantum fabric of planet Earth. For decades, human scientists were utterly baffled by how these birds maintain such flawless direction over intercontinental distances. The revelation came when researchers looked deep into the molecular biology of the avian eye and brain. Ducks possess a groundbreaking biological phenomenon known as magnetoreption, the literal ability to see and feel the Earth's magnetic field lines. Embedded within the specialized proteins called cryptochromes inside their retinas, quantum entanglement occurs. When blue light enters a duck's eye, it triggers a chemical reaction that is hypersensitive to the angle and intensity of the planet's geomagnetic grid. This creates a visual overlay in the duck's field of vision, effectively painting the magnetic north and south poles directly onto their view of the sky. They are not guessing where north is. They can see it as a shifting gradient of light and shadow superimposed over the physical landscape. This quantum compass is backed up by a secondary, redundant navigation system that tracks the celestial theater. Ducks possess an acute sensitivity to the polarized light patterns of the sun, allowing them to calculate their exact geographical position even on heavily overcast days when the sun is completely hidden behind dense cloud cover. At night, their internal computers switch gears, tracking the rotation of the stars around the celestial poles. They analyze the cosmic landscape with rapid-fire cognitive processing, using the constellations as a massive, rotating map to verify their trajectory. Furthermore, their ears are tuned to infrasound, ultra-low-frequency acoustic waves generated by the distant crashing of ocean waves against coastlines or the wind whistling through massive mountain ranges thousands of miles away. They can hear the structural layout of the continents long before they can see them, navigating by a deep, planetary symphony that humans are entirely deaf to. To fuel this high-speed, long-distance migration, the duck's internal physiology undergoes a radical, terrifying transformation. Before taking flight, they enter a state of hyperphagia, consuming massive amounts of high-energy seeds and aquatic invertebrates to pack on layers of dense lipid fat. But they don't just get heavy, they restructure their internal anatomy. To optimize their power-to-weight ratio for flight, ducks can voluntarily shrink their internal digestive organs, including their stomach and intestines, reducing unnecessary weight. Simultaneously, their flight muscles and heart hypertrophy, expanding in size and packing with specialized oxygen-binding proteins to handle the extreme cardiovascular stress of high-altitude travel. They can ascend into the freezing, oxygen-depleted layers of the upper atmosphere, flying comfortably at altitudes where humans would lose consciousness within seconds, using the high-velocity jet streams to propel them across geopolitical borders at breakneck speeds. This intercontinental movement turns a global duck population into a massive, fluid network that links disparate ecosystems across the planet. They are the true owners of the global flyways, the Atlantic, Mississippi, Central, and Pacific superhighways of the sky. As they travel, they carry with them millions of tons of biological data, transporting seeds, microscopic organisms, and nutrients across vast geographic barriers that stop other species completely in their tracks. They ignore human borders, passport controls, and engineered landscapes, treating the entire planet as a single, continuous, interconnected matrix of wetlands. But this infinite mobility does not just make them efficient travelers. It makes them incredibly dangerous vectors of genetic information, possessing a collective intelligence that allows them to communicate, adapt, and organize their societies with chilling precision. The common perception of the duck as an unintelligent bird is a direct result of human arrogance, because their expressions are locked behind a rigid, keratinized bill, we fail to read the intense, calculated cognitive processing occurring behind their eyes. In reality, ducks possess a highly complex social architecture and an advanced acoustic language consisting of dozens of specialized vocalizations, whistles, and body movements designed to coordinate group behavior with absolute clarity. They do not live in random aggregations. They live in highly organized, fluid societies where every individual is constantly monitoring the sensory inputs of the collective. This intelligence is backed by an extraordinary level of visual and spatial awareness. A duck can process visual information up to twice as fast as a human being, meaning that what looks like a continuous blur of motion to us is perceived by the duck as a slow, easily analytical sequence of events. The most terrifying manifestation of this cognitive adaptability is their ability to execute abstract concept learning. In controlled laboratory experiments, ducklings just hours out of the shell were presented with pairs of objects that were either identical in shape and color or completely different. When later tested with entirely new shapes and colors, the ducklings consistently chose pairs that exhibited the same abstract relationship, either sameness or difference, that they had first observed. This means that a newborn duckling, without any prior training, possesses the innate ability to understand higher-order relational concepts. This level of logical processing matches primates and dolphins, allowing ducks to instantly analyze new environments, distinguish friend from foe, and adapt to completely unprecedented survival challenges faster than almost any other bird on Earth. This advanced cognitive processing poses a fundamental biological dilemma. How does an animal with such a highly active, information-hungry brain rest in a world crawling with apex predators? The answer is one of the most chilling evolutionary adaptations in the history of life: unihemispheric slow-wave sleep. When a flock of ducks settles down on a shoreline or water body to rest for the night, they do not all close their eyes and drift into vulnerability. Instead, they arrange themselves into a tight, tactical line. The ducks positioned in the center of the group will close both eyes and sleep with both hemispheres of their brain fully shut down, protected by their peers. But the sentinel ducks positioned on the absolute flanks of the line execute a partial lockdown. They shut down only one half of their brain, closing the corresponding eye to rest that specific cerebral hemisphere. The other eye remains wide open, alert, and tracking the darkness, connected directly to the fully awake and operational half of the brain. During this state of split consciousness, the sentinel duck's open eye scans the environment for the slightest twitch of a predator's shadow or the faint ripple of water. The awake hemisphere of the brain instantly processes the sensory data with full analytical accuracy, while the other hemisphere enjoys deep, restorative sleep. Every few hours, the ducks within the line will voluntarily rotate their positions or simply turn around, closing the eye that was awake and opening the one that was asleep, effectively switching the active hemisphere of their brain without ever waking up. This means a flock of ducks is never truly asleep. They operate as a continuous 24-hour surveillance grid where someone is always watching, always calculating, and always ready to launch the collective at the first sign of infiltration. This psychological resilience makes them almost impossible to surprise or eradicate. Whether they are dealing with a camouflaged human hunter in a modern blind, a stealthy mink creeping through the shoreline reeds, or an aerial hawk diving from the clouds, the duck's collective sensory matrix detects the anomaly and flashes it through the group like an electric current. They don't panic. They calculate the escape vector. If the threat is terrestrial, they slide silently out into the deep, defensive center of the open water. If the threat is aquatic, they launch vertically into the sky in a synchronized explosion of feathers and air pressure. They have turned the simple act of resting into a militarized defense protocol, ensuring that their genetic line remains unbroken through the darkest nights. And it is this exact, unbreakable survival drive that has allowed them to face the terrifying onslaught of human industrial expansion head-on. When humanity began its aggressive campaign to alter the face of the earth, draining wetlands, pouring concrete over pristine ecosystems, and constructing sprawling megacities, thousands of specialized animal species looked at the changing world and quietly slipped into extinction. They could not handle the noise, the pollution, or the fragmentation of their habitats. But the duck did not retreat. Instead, it looked at the concrete grids of human civilization and saw an open invitation for territorial expansion. Ducks are the ultimate biological generalists, possessing an evolutionary toolkit so diverse and a digestive system so adaptable that human urbanization did not destroy them. It amplified them. They transformed our decorative urban parks, artificial retention ponds, golf course hazards, and agricultural drainage ditches into a highly productive, artificial network of thriving ecosystems. The secret to this incredible resilience lies within the structural layout of their bills. A duck's bill is not just a blunt instrument for grabbing food. It is a hypersensitive, tactile sensory organ lined with thousands of microscopic nerve endings called Herb's corpuscles. This design acts like a biological touch sensor, allowing the duck to feel through thick, pitch-black mud, industrial sludge, or dense aquatic weeds to identify edible organic material without needing to see it. Furthermore, the inner edges of their bills are lined with rows of fine, comb-like structures called lamellae. When a duck feeds, it acts like a living filtration pump. It draws water and mud into the front of its bill and expels it out the sides through the lamellae, trapping seeds, small insects, mollusks, and plant matter with absolute efficiency. They can filter out microplastics, agricultural runoff, and urban debris, extracting pure caloric energy from environments that would poison other life forms. This dietary flexibility has allowed them to turn human agriculture into a massive, infinite fuel source. When millions of acres of wild landscape were cleared to plant monocultures of rice, corn, wheat, and barley, the ducks did not starve. They adapted their migration routes to align perfectly with a human harvest calendar. After the massive combines clear the fields, vast flocks of ducks descend upon the agricultural waste, consuming the dropped grain by the ton. They convert human industrial output directly into avian biomass. In countries across Asia, this relationship has been formalized into an ancient, highly efficient system known as duck rice farming. Instead of using chemical pesticides and heavy machinery, farmers release thousands of ducks directly into the flooded rice paddies. The ducks move through the crops like a systematic cleaning crew, devouring destructive insects, stripping away competing weeds, and fertilizing the soil with their highly concentrated nitrogenous waste, all while growing fat on the system's byproduct. But this intense adaptability has a dark, highly volatile ecological flip side. By integrating themselves so deeply into both human agricultural systems and urban environments, ducks have become the primary global reservoir for some of the most mutable pathogens on the planet, most notably avian influenza. In their wild populations, these viruses often exist in a stable, non-lethal equilibrium, moving harmlessly through the duck's highly resilient digestive tracts. But as these birds move seamlessly between wild, pristine wetlands, crowded urban parks, and intensive industrial poultry facilities, they act as the ultimate genetic bridge. They transport viral strains across continents in a matter of days, exposing domestic livestock and human populations to rapidly evolving biological threats. The duck's immune system is a battleground of constant, high-stakes genetic warfare, managing pathogens that have the potential to rewrite human history with a single mutation. Despite this biological tension, human attempts to control or eradicate urban duck populations have met with total failure. If a city attempts to clear a lake or thin a flock, the ducks exploit their high reproductive plasticity. A single female duck can lay a clutch of up to 15 eggs and can successfully raise multiple broods in a single season if resources are abundant. They hide their nests with masterclass camouflage in suburban flower beds, industrial courtyards, and highway medians, right under the noses of human populations. The moment the pressure relents, their numbers explode back to maximum capacity. They have mastered the art of urban guerrilla survival, turning our own engineered infrastructure into a defensive shield that protects them from their traditional wild predators. They have embedded themselves into the human world so deeply that they are now entirely inseparable from our global landscape, silently preparing for whatever epoch comes next. If human civilization were to fracture and collapse under the weight of its own technological complexity, the concrete empires we have built would undergo a rapid, watery transformation. Without human engineers to constantly clear drainage networks, maintain massive levee systems, and operate industrial water pumps, the world's low-lying urban areas, coastal metropolises, and vast agricultural plains would quickly flood. Major cities would transform into sprawling, semi-aquatic labyrinths of flooded streets, stagnant canals, and submerged structural ruins. For the vast majority of terrestrial mammals and highly specialized species, this sudden deluge would mean absolute displacement and death. But for the global duck population, this scenario would represent the ultimate evolutionary jackpot. The apocalypse flock would not merely survive the collapse of the human matrix. They would instantly step into the vacuum as the prime amphibious heirs of the ruined planet. As the concrete structures decay and become covered in algae, moss, and dense aquatic vegetation, the ducks would deploy their multi-terrain mobility to conquer this new world with terrifying efficiency. The abandoned skyscrapers and flooded parking structures would serve as massive, vertical artificial cliffs, offering predator-free nesting sites and high-altitude lookout points far out of reach of any surviving ground carnivores. The vast networks of flooded roadways would become endless, high-energy foraging canals where their hypersensitive bills could filter out the rich organic detritus of a decaying civilization. Their unihemispheric sleep lock would allow them to maintain a flawless, unbroken defense grid across the open, flooded ruins, ensuring that no emerging predatory threat could ever catch the collective off guard. Without human hunting pressure and industrial pollution, their genetic diversity would explode. Free from the selective constraints of the old world, different duck populations would rapidly mutate and adapt to fill the thousands of vacant ecological niches left behind by extinct species. Over deep evolutionary time, the structural mechanics that make them the perfect amphibious machine would diversify into bizarre new forms. We might see massive, flightless diving ducks that reclaim the deep ocean niches, navigating the sunken coastal cities like feathered seals. Other lineages might optimize their high-speed aerodynamic design, turning into hyper-predatory aerial hunters that dominate the skies. Their volatile, highly adaptable genome would allow them to morph into whatever shape the new ecosystem requires, proving that their thousands of years spent alongside humanity were nothing more than a minor historical footnote in their millions of years of planetary dominance. The duck has played the ultimate evolutionary long game. They survived the extinction events that wiped out the ancient terrestrial giants. They adapted seamlessly to the violent, chaotic rise of human industrialization, and they have kept their prime-val, multi-terrain survival software fully updated and operational. They did not need our protection, they did not need our cities, and they certainly never needed our permission to thrive. They simply used our global trade routes, our agricultural outputs, and our artificial landscapes to maximize their geographical distribution across every corner of the globe, waiting patiently for our fragile global systems to crack. As the human era inevitably draws to a close, the silent, feathered grid will remain fully intact, floating effortlessly on the rising waters, ready to claim their absolute, unbroken sovereignty over the aquatic horizon of Earth. If you want to unearth the hidden, deep evolutionary secrets of the animal kingdom and explore the terrifying biological forces that secretly control the landscapes of our world, make sure to subscribe to the channel, activate all notifications, and drop a comment below with your thoughts on this unstoppable amphibious superpower.